Hello class, in this video we will talk about the simple linear regression and multiple regression in chapter 7. The rest of the topics in this chapter will be discussed next Monday when we have class. So this whole chapter is about developing regression analysis using different regression techniques. So why are we doing this regression analysis? So when we make decisions, when we make predictions, we need to find the relationship between different variables. For example, if you want to do some advertisement campaign or you want to do some promotion, you want to estimate or you want to find the relationship between the revenue or the sales and the money you put in your advertisement or promotion. Then based on the money you put in, you can predict what sales or what revenue you can expect, so that if the revenue or the sales is high enough, okay, that will justify your strategy or your investment. So in this case, a marketing manager may attempt to predict the sales for given level of advertising expenditures. Okay? So that is just one example. So in order to build the relationship between the sales or revenue and the money you put in, you have to do some regression analysis using the historical data. So that's why we do regression analysis. And as I said, in this video, we will talk about two regression techniques. One is simple linear, the other is multiple linear regression. But before that, let's review some of the terms we learned in this class and the statistics. So the first one is called dependent variable or response variable. So that is the variable we want to predict. For example, if you want to predict the sales or revenue, so the revenue will be your dependent variable or response variable. So why it's called dependent variable? Because the value of that variable or the value of revenue depends on some other variables. So some other variables are called independent variables or predictor variable. So those are the variables being used to predict the value of the dependent variable. For example, the money you put in, your promotions or advertisements, so that's independent variable. So that will affect or determine your revenue or sales. So let's start with the simple linear regression. So this equation shows a general form of simple linear regression model for the population. So it's y is equal to beta 0 plus beta 1 times x plus an error term. So here we have one dependent variable y and the one independent variable x, and beta 0 is called intercept and beta 1 is called slope, and this Greek letter epsilon is the error term. So this is the general format for the regression model for the population. We want to estimate the beta 0 and beta 1. So how do we do this estimation? We have to rely on the sample, rely on our data. So we can consider the beta 0 and beta 1 are, say, population parameters. So in the previous chapters, we learned how to estimate population parameters using samples. Similar story here. So how do we do the estimation? So this equation is the estimated simple linear regression equation. In this equation, we dropped the error term and we changed the beta 0 to B0 and beta 1 to B1, because B0 and B1 are estimators of those two parameters. So we call them sample statistics. So we use those two terms to estimate beta 0 and beta 1. So because those terms are based on the sample, they are not population parameters. So this form is learned in statistics class, so I will go over this very quickly. So in our regression model, so we use y hat because when this is an estimated value, it's not the real y value. So to differentiate between the estimated value and the actual value, we use the hat. So this is a hat. Whenever you see this hat, that means it's an estimated value. Okay? So B0 is the intercept, and B1 is the slope. Okay? So the y hat is the point estimator. It's a point estimator of the mean of the y value or expected y value given a x value. So here's how we do this simple linear regression, how to estimate the beta 0, beta 1 by getting the B0 and B1. So this is a general form we just discussed. So we don't know those parameters, but we want to estimate those two parameters. So how do we do that? We get our sample. So we get the x values, y values. Those are the real data. Those are the sample data we collect. And then we use those data to formulate this estimated regression model or equation. And the B0 and B1 are estimated using those sample data we have. So by the end of this step, we should have the B0 and B1. Then we will have those estimates for the beta 0 and B1. So that's the whole process of doing the linear regression. So for simple linear regression, we have three scenarios. So the first figure shows a positive linear relationship. So we have x variable and estimated y value. So if you see the line, the regression line is positive. So meaning that slope B1 is a positive value. So some examples could be your investment in marketing or promotion. So the more money you put in your advertisement or promotion, the higher revenue will become. So that's a positive relationship. And the second one shows a negative relationship, which means the B1 is a negative value. So one example could be so for x, the time you spend in doing exercise, and the estimate the y means the chance of getting sick. Okay, so when we spend more time doing exercise, the lower chance we will have disease or we get sick. And if there's no relationship, then the B1 is 0. That means y does not depend on x variable.